Hi guys, welcome to COSC330 530 Parallel and Distributed Computing, and welcome to the Moodle homepage for COSC330 530. My name is Mitchell Welch and I'm going to be the unit coordinator for this subject in 2019, and today we're just going to have a quick look through the Moodle page, go over some of the things that you can expect to study this unit, and have a quick look at some of the assessment tasks and some of the resources that are available. So as I mentioned before, this is the Moodle homepage. This is where all of the content for the unit's going to be presented to you. So if you want to access any of the lectures, any of the assignments, this is the place to go. Most of the content lives under these tiles presented down here. So your assessment tasks are all listed under the assessment tasks tiles. And then this unit's broken down into 4 modules. So you've got multi-process programming, multi-threaded programming, distributed computing with MPI, and CUDA programming, all nestled away into these topic blocks down here. But we're going to concentrate on this top section in this introduction video. So if we have a quick look at the unit overview and unit information, this is where all of the basic info about the unit lives. So you've got a little bit of a welcoming text here. So really what we want to know here is part of the motivation. Why are we studying parallel programming? And the answer to that is actually in the first lecture, but I'll just introduce quickly this graph here. And this graph shows a couple of important things. It shows the number of transistors on our computer chips. It shows that's increasing over time. It stops out at about 2010, this image, but this trend's continued, and it shows the clock speed trend. So you can see up until sort of the mid-2000s, the clock speeds were getting faster in our processors as the transistors improved there. So as software developers, we were kind of getting a bit of a free ride here. As the clock speed improved, the speed of our software improved along the way until we get to this point here in 2005. From 2005 onwards, and something interesting happened here. We started producing devices that devoted more of the transistors to having more processing cores, as opposed to producing faster processors. And so this trend, if we look at some of the more recent chips that are available, so if we look at a typical Intel processor, this is an i9 processor. Here the specifications are just off the Intel page. You can see here that it has 6 cores and offers us 12 operating system threads here. So that means that you've got this opportunity to exploit the hardware and create software that can run that can do multiple things at once. You've got at least 6 hardware cores, so you've got 6 parallel processors that can be working together to solve a problem. And this trend has sort of gone right through. So AMD have their Threadripper processors, which have about 32 cores and give us 64 threads. But even with our mobile devices, so if we look at the Apple A12 processor that's in most of the recent iDevices, so you've got a hexacore processor here with 2 high-speed cores and 4 high-efficiency cores. So again, even very small devices with very efficient processors are multi-core, so they can achieve parallelism. So same with our Samsung devices. If we look at our ARM chips that live, the Snapdragon chips that live inside the ARM devices, they're sort of quad and hexacore processors as well. So we need to be able to write software to exploit this new hardware in order to get our performance boost. And if we think about even just our desktop computer, we've got lots of things going on at once. So we've got things like the operating system updating and repairing itself. We've got our antivirus software working away, screening links and screening files as we open them. And in order for our system to really work smoothly, these devices, this software needs to exploit these parallel computing devices. That's really why we're here. So moving through in this unit, we're going to be covering off on a lot of the low level. So when I say low level, working closely with the hardware, low level programming paradigms and programming features that you need to understand in order to effectively build parallel programs. So the learning outcomes for this unit are sort of focused around that. So you'll be understanding modern parallel programs. You'll be able to solve problems and implement parallelization strategies. And this really cuts to the core of what you'll be learning in this subject, learning how to take a problem and work out which bits of it can be executed in parallel. You'll develop software for a range of parallel architectures. So this will include multi-process programs that run on your traditional multi-core processors, multi-threaded programs that use sort of software threads, and you'll also look at message passing interface to develop software that runs on clusters of computers, and you'll finish up by looking at NVIDIA CUDA. So you'll be running highly parallel programs that run on the very advanced and very effective GPU hardware. And the 530 students, you'll be working on some more intensive problems there. Your project at the end will require you to implement some more tricky parallelization strategies. So I am the primary contact for this unit, so if you have any problems, just send through an email. I'm mwelch8@une.edu.au. If you have any problems, just let me know and we can sort through them. The prescribed material for this subject is the advanced programming in the Unix environment, and there's a recommended text, which is an introduction to parallel programming. So the advanced programming in the Unix environment text really focuses on the first two modules, and the parallel programming text is focused on the third module, and the final module is all done from the online documentation that's provided by NVIDIA. So if you can get access to copies of those texts, they'll be there to support your study as you move through. Our study timetable is pretty much what you'd expect. Basically, we have two lecture videos for you to review each week. You've got our topics here listed, and you'll have 4 assignments dotted through this unit, 5 if you're in COSC330, so you've got a project due in at the end. The assignments are due in on the Monday of the week that they're listed, so you can see those due dates in the Moodle page in the assignment tile. So start on these early. So all of the assignments in COSC330 530 are all programming assignments. So you're going to be coding stuff up, solving some at times challenging problems. So make sure you start early and ask questions, get on the discussion forums, and if you're on campus, we'll be working closely with you in the practical sessions as we move through. So as I mentioned before, you've got 2 one-hour lectures. The videos usually don't go for an hour. They're usually around 40 minutes, and that's how the material will be presented. And each week you'll have a workshop. So if you're studying this subject on campus as an internal student, you'll have a 3-hour lab session each week, and that's where we'll work together to go through the practical sessions, the practical material, and we'll be working on working through lecture material that you have questions about as well. So if you have any questions, you've just got the usual boilerplate items here as well that cover off on the expectations and students and staff. And there's no intensive school for this subject. It's all completely online. Should you want, you've just got an exam to attend at the end, and you have to pass all of the assignments. So you have to get an overall grade, of 50% in the assignment component, and you have to pass the exam to pass the unit. So it's mandatory to pass the final exam that sits at the end for both COSC330 and 530. So if we jump back through to our home page here, we can see we've got this unit resources tile. So the unit resources tile just has a few sort of helpful links here. This is where the welcome video, this is last year's welcome video because I'm currently recording the current one. This is where your welcome video will sit, but you've also got a guide to the command line assignment submission system. So the submit program. And this is how you will submit your assignments. So this is basically just a custom program that allows you to submit your files through Turing, and it allows you to record a script, a command line script of your assignment, working just before submission, so that we know that at the point of submission your program did actually work. So go through and have a read of the assignment submission guidelines, the assignment submission guide. We also have some other useful bits and pieces here. So there's a quick cheat sheet that covers off on some of the Unix programming tools, in particular the compilers. So the GCC compiler we'll be using, and Makefiles, if you're not familiar with them. So go through and have a quick read of those. That's just a cheat sheet. At the end, it also has some command line, has the Unix shell command lines as well. So just a quick cheat sheet for some commonly used command line tools that you might need. And go through and have a look through the other resources there. They're just bits and pieces that you might find interesting as you progress through the unit. As I mentioned before, your assessment tasks can all be found in the assessment tasks tile. Your tile will look a little bit different from mine because I've got access to all of the assignments, but if you click on this, on the assignment links, go through, these will link through to the assignment content. So here we have assignment 1, which is all about cracking a cipher. You can go through and start working on that one once we've covered off on the multi-process programming content. And moving back to our home page here, you can see you've got your 4 topic tiles. So multi-process programming is the first one. If you go into here, you can see all of the slides are uploaded. We use a web slide system to present these slides, so you can just pan through these with your scroll or your keys on your keyboard to look at the slides. We also have a notes view. If you go to the notes online view, you can see that we've got these slides, all of the content shown in a scrollable fashion here, and it also includes all of the code snippets, which are a bit easier to view in the notes view. So go through, have a look at those. As we move through, you can decide which paradigm best suits you. So at each week, you've got a self-check exercise. So these are listed in the practical sessions section down here, because for internal students, we'll be running through these self-check exercises each week, and in here there's a series of questions in here, and we have some answer reference links. These link directly to the slides that refer to the answers to the questions. So these are sort of just some simple comprehension questions that look at things that you should understand. They're also really good revision for the final exam. So these are really that you can expect to have questions like this in your final exam. So go through. If you go through and have answers to all of them, you won't have any problems at the end of your unit. And in addition to your self-check exercises, each week you'll have a practical exercise. These are usually very closely related to what we've been covering in the lectures. In fact, they usually cover off on a lot of the examples where you'll be compiling them, making changes to them, and just basically improving your understanding of how parallel programs work within the different paradigms that we adopt, that we study here. So go through, work through these each week, and these will build you up to where you can complete the assessment tasks. And so this is the format of all of the topic tiles. So before we move on, as you might have gathered by now, this is a very technical unit. All of the assignments involve programming, and so the prerequisite knowledge for this unit is that you're proficient with programming and preferably proficient in programming in C or C++. So if you've completed either COSC330 or COSC340, which are the 200 level second year units here at UNE, you should be fine to jump straight into the content for this unit. If you haven't, or you're studying the postgraduate version of this course, you might need to go through and have a look at some online tutorials, or send me through an email and I can recommend some content for you to review to get you up to speed with programming in C and C++. Usually, if you've got any reasonable programming experience in any programming language, so like Python or Java, learning C and C++ isn't particularly difficult, and most of the examples that we start off with in the first couple of weeks walk you into the programming quite slowly, but you are expected to have that baseline knowledge there. So if you have any questions, please email in. Otherwise, good luck in your studies in trimester 2, and good luck with COSC 330 530. Thanks, guys.